Part 4 of the question asks us to show that the minimum total surface area of the box occurs when x is equal to 0.5 metres, and then we are to find the minimum surface area that will enclose that given volume. So let's write down the expression for our total surface area again. It's equal to -4 outside of x squared minus x minus 2 over x outside of 1 take x. So for this expression to be a minimum, we want the derivative of the area with respect to x to be equal to 0. So we need to differentiate this expression now with respect to x. In order to do that, it's probably easier to split the final term there, the 2 over x outside of 1 minus x, into partial fractions. So let's just quickly do that. 2 over x outside of 1 take x is equal to a over x plus b over 1 minus x. They're the two partial fractions that we're looking for. Cross multiplying there gives us 2 equal to a outside of 1 minus x plus b times x. Now that's true for all values of x, so we can choose values of x that will help us to solve that. If x is equal to 1, then the first bracket there is equal to 0, and we can solve that b times 1 equal to 2 or b equals 2. Secondly, if we choose the value of x equal to 0, then the second term drops out, the b term drops out, and again we get 2 equal to 1 lot of a, if you like, and quickly see that that's equal to 2. So our partial fractions then, or the area expressed in its simplest form, ready for differentiation, will be a equals -4 outside of x squared minus x minus 2 over x plus 2 over 1 take x. Now we can differentiate. The derivative of a with respect to x is -4. Derivative of the x squared term is just 2x. The derivative of the negative x term is -1. Now carefully, our derivatives of our last two terms need to be very careful here with the negative signs as we do the differentiation. Derivative of 2 over x, or 2 by x to the -1, is going to be -2 over x squared. The second term in the expression, again being very careful with the negative signs here, it will be 2 over 1 minus x squared by -1. So it leaves the sign inside the bracket as a positive sign. And if you need some help with that, then you need to look at the videos on differentiating rational expressions where the rational expression is in the denominator. Carefully taking the negative sign through the second bracket then, we get this equal to -4 outside of 2x minus 1 plus 2 over x squared minus 2 over 1 minus x squared, and now we need to take the -4 through the bracket. And so that's our expression then for the derivative, dA dx. Now, for this to be a minimum, then dA dx has to be equal to 0. So we can set up our equation to solve for x. 0 equals -4 outside of 2x minus 1 plus 2 over x squared minus 2 over 1 minus x all squared. Now the 4 will disappear if we divide both sides by 4. 0 divided by -4 is just 0 still. So that removes that factor of 4 out of the front. And the equation we need to solve then becomes 2x minus 1 plus 2 over x squared minus 2 over 1 take x squared equals 0. Let's clear the denominators. We'll firstly multiply through by x squared. This gives us 2x cubed minus x squared plus 2 minus 2x squared over 1 minus x all squared equals 0. Clearing the second fraction, we need to multiply everything by 1 minus x all squared now. So this gives us 2x cubed outside of 1 minus x all squared minus x squared outside of 1 minus x all squared plus 2 outside of 1 minus x all squared, and our last term just -2x squared equals 0. Again, very carefully expanding the brackets and being careful with our signs, extra careful with our signs. We don't want to drop a negative sign here. Expanding 1 minus x squared, we get 2x cubed outside of 1 minus 2x plus x squared, minus x squared outside of 1 minus 2x plus x squared, plus 2 outside of 1 minus 2x plus x squared, minus 2x, all equal to 0. Expand the brackets again now. 2x cubed minus 4x to the 4th plus 2x to the 5th minus x squared plus 2x cubed minus x to the 4th plus 2 minus 4x plus 2x squared minus 2x squared equals 0. Now the only terms that will disappear from this expression are the plus 2x squared and the minus 2x squared at the end. So let's now write the expression in terms of descending powers of x. So we have a 2x to the 5th. We have minus 5x to the 4th. 4x cubed minus an x squared minus 4x plus 2 equals to 0. Now this is the sort of equation that nobody expects you to be able to do in your head. We do suspect that x equals a half is a solution to it though, because we were given that in the problem, in the original posing of the question. So let's quickly sketch the graph using a bit of software of this curve and see what it looks like. You can see when we sketch the curve that we do actually have a solution at x equals 0.5. Now we know that x equals 0.5 is a local minimum because to the left of x equals 0.5 the gradient is negative, and to the right of x equals 0.5 the gradient is positive. So the values of this graph actually give you the sign of the gradient. So we can see there's a solution there at x equals 0.5. Let's in fact prove that to ourselves by substituting x equals a half into our equation. So we get 2 times 1/2 to the 5th, which is 2 times 1/32, minus 5 times a half to the 4th, 5 times 1/16, plus 4 times a half cubed, 4 times 1/8, minus a half squared, minus 4 times a half, plus 2. Let's write these as sixteenths. So 2 times a 32nd is 1/16. 5 times a 16th is obviously 5/16. 4 times an 1/8 is a half, or 8/16. Minus a quarter we can write as 4/16. 4 times a half is 2, we can write that as 32/16. Plus 2 we can write that as 32/16. And you can see the last two expressions cancel each other out, so they disappear. And let's see how many sixteenths we've got left. 0. So you can see that x equals 0.5 or a half is a solution to a rather complicated equation up above. We need to find the minimum total surface area. So that occurs when x is equal to 0.5, so we need to substitute this back into our expression for the total surface area. We might just copy that back in here. Our expression for the total surface area was minus 4 outside of x squared minus x, negative bracket 2 over x plus 2 over 1 minus x. That's our expression for the total surface area, and we now need to substitute x equals a half into that. So we get a equals minus 4 outside of a half squared, which is a quarter, minus a half, minus 2 over a half, minus 2 over 1 minus a half, which is again 2 over a half. Simplifying this now, we can write 2 over a half as 2 times 2, just flipping the half in the denominator. And that, of course, is 4. And again, we get a second 4 there. Next line, let's write all of these as quarters. So we've got 1 quarter minus 2 quarters minus 32 quarters. And you can see that if we take the 4 through the bracket, that the 4's in the denominators disappear. Leaves us with a negative sign outside of the bracket. Let's distribute the negative sign through the bracket. Minus 1 plus 2 plus 32. Sorry, that's equal to 33 square metres, which is the minimum total surface area to enclose an 8 metre cubed volume. The last part of the problem asks us to calculate the length that needs to be cut off the roll of metal to make the box. Let's just reacquaint ourselves with the original diagram and copy it back in here. So remember that y is the solution that we're looking for here, and copying our expression for y in terms of x, y equals 2x plus 4 over x minus x squared, or if you like, in its factorised form, 2x plus 4 over x outside of 1 minus x. So substituting x equals a half into that equation gives us y equals 2 times a half over 4 outside of a half times a half, or a half squared. And if you evaluate that quickly, you'll see that that's 1 plus 16, or 17 metres. So the length that needs to be cut off the roll to make the box with a minimum surface area is 17 metres. And here are 2 screens which show the problem in its entirety.
For more free tutorials and the PDF for this tutorial, visit www.handwrittentutorials.com.